strings, and I don't think I'll talk about that today. That's really the side point. What I'd like to talk about is just this code again to remind you of how this worked. And then I'd like to generalize this code. And the way that will happen is I will wrap it up into a function. We're still function writers, even though this is a new chapter, chapter 3. So let us begin to write functions. That's almost exclusively what we will do in this chapter throughout the class. Okay, but just a reminder, okay? So what this code did, again, is it stepped through a list and it added each new element of the list into a sum and then reported what that sum is. That is, it summed up all the elements in a list. Okay. Now, here is the basic logic behind how that is done. Line number 1, you initialize a variable that will hold that sum, called sum element. Each new element will be added into that, and we'll talk about how that's done in just a second. But you cannot add something into it unless it has a value to begin with. That means you have to initialize it. And since this is a sum, ultimately, the appropriate initial value is 0. Okay, that's the number such that when you add it, you do not change what the sum is. So we initialize 0. And then on line number 2, we begin the definite iteration. We begin the loop. Okay, we had 2 new keywords. Those keywords are for and in. You see them there. Oh, I actually looked up and got a little bit clearer what precisely is meant by keyword in Python. Yeah, they are words that come predefined in Python, but they're also words that you absolutely cannot use in any other way. Let me just show you very quickly. I was amused by this. So the keywords that we've seen so far, I'll keep these up on the board, are def, return, pass, for, and in. And if you try to use one of those in some other way, like for instance use def just like it's a normal variable, Python will absolutely scream at you about that and will not allow you to do that. However, and I wasn't really clear about this, there are other words sort of predefined by Python that are not called keywords, and those you can override, like built-in function names. You remember the print function, of course, we used it in chapter 1. Here's something quite extraordinary you can do, and I don't really like it, and you shouldn't do it, but it is possible. I can treat print as if it's just a variable name, and then it becomes one. And then what otherwise I would have been able to do, that is, print some object like the string dogs and cats, which before would have worked, but now print refers to the number 2, which means that this crashes. So here's something really evil that you can do with somebody's code if it's Python. You could go and override one of the built-in functions. Like maybe they use the print function all over the place. So you could slip in a line of code at line 123 that says print is equal to the number 2, and then everything breaks. And they go, what in the world? What is it? I kind of don't like it, but Python allows you to do it. Anyway, back to the line of code. We had 2 new keywords, the for and the in. What comes in between them, in this case the item, that's a variable. It can be whatever I want. I spelled it the way I want it to, I-T-E-M. And then what comes after the keyword in is some sequence, okay? There are various kinds of sequences in Python. That's a list. We saw how to make lists. It's the open square bracket and then the object separated by commas and then the closed square bracket. That sequence could be a string. We'll see that at some point in time. It could be something called a dictionary. It could be something called a set. We'll see other kinds of sequences later on. But for us now, it will be just a list. And you can see the items that were in the list. And then what happens when you run the code is this. And you can see this. Okay, you can see it happen. Question?
I must have missed this yesterday. What's the plus and minus, or the plus equals?
I will tell you. You didn't miss it yesterday because we didn't talk about it. But I had a student in period 2 today that did want to talk about it. So we talked about it.
Okay.
And I will show you. That's a perceptive remark. Okay, so what happened was this. Okay, so we've got the first line of the loop that's there on line number 2. The end is the colon, right? Which means that we have an indented line after it, actually 2 indented lines. That's the body of the loop. And the body of the loop executes multiple times, once for each item in the list. So we executed lines 3 and 4. For the 17, then 3 and 4 again for the 71, then 3 and 4 again for the 14, and so on. We literally loop. That's what they're called loops. And then finally, last little bit of review, the way the loop variable item works is that the first time we execute lines 3 and 4, item has the value 17. That is variable assignment, and Python does it automatically for us. Okay, so item took the value 17, and then the second time we executed lines 3 and then 4, item had the value 71, and so on. So each time we loop, item takes the next object in the list as its value. And then, of course, once it's gone through all the objects in the list, the loop is complete. And then line number 4, okay? Let me actually put a comment in here, just to make sure that we're clear about this. This is, I'm about to give you a new phrase. That's syntactic sugar for some, and of course you know that this line is a comment, right? This is merely for human readers. Some elem is some elem plus item. That's what that means, okay? It's syntactic sugar. What is syntactic sugar? Well, it's syntax. It has to do with the symbols that you have to use. And it's sugar because it's sweet. What it really allows us to do is just to simplify, okay, to write in a shorter form. So instead of write some elem is some elems plus item, we can simply write some elems plus equal, that's how that's typically read, plus equal item. And what that really does then is it adds in the value of item to the current value of some elems. And then that becomes, of course, the new value of some elems. Just like in line number 5, you know how this works, right? You evaluate the right-hand side first, so you take the current value of some elements, which the first time through that's 0, add in the current value of item, the first time through that's 17, the value that results then becomes the value of some element. So what some elements really does is it evolves, okay? Every time we go through the body of the loop again, it increases by the current value of item. And this is typical of loops, okay? It's not like you just have this block of code and you run it multiple times and it does precisely the same thing every time. In a certain sense it does, yeah, but what can happen is this, is that you can have a variable whose value continues to change with each new loop, okay? What happens to some elements in this case is that in each new loop, it has added in the current value from the list, so by the time we are done, it has the complete sum of all the elements in the list. So that's the basics of iteration. Now what I'd like to do is to generalize. Very often what happens when you write a function is that you generalize. Like, for instance, you remember in chapter 1, we had programs that converted Fahrenheit to Celsius. We had more than one, and they were specific. Like the first one assigned a particular value to Fahrenheit, converted that to Celsius, and then the next chunk assigned a different value to Fahrenheit, and then converted it to Celsius. When we wrote the function that converts Fahrenheit to Celsius, we generalized over that, right? So we have one chunk of code that we can run multiple times that will do the conversion. We're about to do the same, or something like it. The chunk of code that we have, lines 1 through 6, right now, all that it can do is sum up the elements in that given list, the one that goes 17, 71, 14, and so on. We would actually have to go and change the code if we wanted it to sum up a different list. Wouldn't it be nice then to have a single function that would take any list you like and would sum up the elements in that list? Okay, so sort of generalize this idea so that it applies to any list. Well, we can absolutely do that. So let's write a function that does. So let's write a function that'll be some elements list. That is the sum of the elements of a list. And what will it take? That is, what will the input value be? It'll be a list of nums. Okay, so when I call this function, if I call it correctly, the value in parentheses after the function name, that is the argument that I sent to this function, will be some list of numbers. And like any function, I can call it multiple times and I can call it with different lists. And there's your generality for you right there. After this, however, it's very much like what we had. Okay, so we've got some elements that we need to initialize to 0. That's the variable that will add in each new item from the list as we encounter it in the iteration, and then we'll hold the sum of all the elements at the end. So we then now have to engage the iteration. We have to start the loop. So for item n, if you don't like item, call it something else. for elem for number, whatever, for item n, the list of nums. Okay, again, we assume that when we call this function, we'll send it a list. And then we'll use the syntactic sugar version of how it is that we add in the current element to the sum of the elements. So plus equals item. And then, of course, what do we have to do at the end? Not print like we did before, right? That's not really what functions are built to do. You can put print statements in there, but that's not really the point of the function. A return value, that's exactly right. It's not really a function until you return a value. So what we'll return is that sum of the elements. And then let's run it and hope that it doesn't crash. Let me show you something. I talked about how it is that you can disable a chunk of code and not simply delete it. I said you can turn it into a multi-line string with 3 quotation marks at the start and the end. There's another way you can do this. Simply select all of that code and then right-click. You can get a right-click, right? You could also use F1. Do you have function keys? Yeah, no. So you can't use F1. If you had F1, you could use F1. You can use a right-click. And do you see command palette there? These are just various commands that you can send to the code editor. And one of them is add line comment. And do you see what it did? Every line in that selected block of code now has the comment symbol placed in front, so it's been disabled. But it exists, which is good. And there's also a command in the command palette to remove line comments. So you could remove all of those if you like. It's convenient. It's quite convenient to have. Anyway, so let's run. All right, so no crash. That's good. But I hope that you've begun to catch on that we don't simply write functions, run them, and then hope they don't crash. And then if they don't, we're done. No, we have to systematically test them. Systematically test them. Not just a few random test cases, but test cases that give us confidence that the function works for any input value. And that means edge cases as well. And I'll begin in a moment to explain what I mean by edge case. That's language we'll use all throughout the class. So sum of the element of the list, that's the name of our function. And then let's send it a list. I don't really care what we send it. How about we just send it a list that contains a single element initially. And hopefully you can parse this, okay? You need to understand symbol by symbol what this means. So sum elements list, that's the name of the function. The open parenthesis that comes immediately after means that we're about to call the function. That's what name followed by open parenthesis always means in Python. And then what comes after the open parenthesis is the object or objects that we will send to the function when we call it. That is the input values. The input value here is simply the list that contains the integer 1. The square bracket 1 square bracket, that is a list, one list that contains a single element, that is the integer 1. And what should the output be? What is the sum of all the elements of a list whose only element is 1? It should be just 1, right? So it's not enough to test some values, but you should know what the output should be before you do the test, so you can compare the actual output to what it should be. So if it's not the same, you'll know that you have something wrong. Yeah, that works. So let's actually put some more values in. How about 1 and 2 and negative 4 and 7? What should that be? 6, I guess. I think this actually works. Now, let's test an edge case. This is like the edge case in this for this function. An edge case is like if you consider all the possible objects that you can send to the function, it's like the one at the very edge of what's possible, right? So you could have lists that are 10 long, 9 long, 7 long, down to lists that are 0 long. That is truly the edge of possible inputs. And very often when functions break, they break at the edge, which is the way that it goes. Perhaps this will seem a little mysterious, okay? So what I have inside of parentheses here, that is the object that I will send to the function, is just a square bracket and then immediately after another, open and then close. That is a list, but it is a list that contains no objects at all. It has a name. Does anybody happen to know what that name is? A list that contains no elements at all.
An empty list.
The empty list is exactly right. That's what it should be called, and that is correct. There will also later on be the empty string, that is the string that contains no characters at all. You might wonder why in the world you would want something like that. It seems a little strange, I know, but when we get to the chapter on lists, and we have an entire chapter devoted to them, you will understand quite clearly why the empty list is necessary. But that point to the side, what I'm about to do is send the empty list to this function. And before we hit return, let's actually think about what the function will do. Okay? So the value of list nums will be the empty list after I hit return. Okay? The parameters value will be that, the empty list. And then we'll execute the code, right, in the body of the function. So we'll execute line number 9, which means that some elements will become 0. And then we'll execute line number 10, which says for item in list nums. Oh, but list nums will be the empty list. And the empty list contains how many elements? 0. That means that this for loop, its body, will execute once per item in the empty list. So how many times will line number 11 execute? 0, which is actually instructive. There is no reason to assume that in all cases, a loop will actually execute even once. If you send it an empty sequence, that is a sequence that contains no elements at all, like the empty list, the body, in this case line 11, will never execute. And what that means is that the value of some elements will never change. That means that when we return some element on line number 12, it will have to be 0. And it is. And I'm fine with that, okay? I'm totally fine with this result. That is, the sum of all the elements in the empty list is 0, okay? I think actually that's what this function should do. All right, so that's a bit of review about what definite iteration is, about how you set it up. And this is also now how you generalize the work that we did before with the creation of a function. And I think I'll stop right there.